All right, so our number 25, if something's on the unit circle, we can just go 90, 30, we're back a half up about 0.9. So we can just get it that way. Some teachers only teach right triangles in that first quadrant. So a student that doesn't know the unit circle, they would actually have to do a trig identity to get that because they just wouldn't know it. All right, they'd only know up to 90. All right, here. Happen if you wanted to do sum or difference. Now, you could do what adds up. 90 and 30 would work. 180 minus 60. There's other options. I just did cosine of alpha plus beta. All right, because I'm in quadrant 1. That made it kind of easy. So it's cosine, cosine, sine, sine. My advice to you, if you write too much, you're going to screw it up. So number 1, just write the formula. Just put alpha and beta above. And then underneath, these guys spit out ratios, right? Like the input is an angle, the output is a ratio. So under here, just put 4. I just usually do like 4 fill in the blanks, like that. And then I stick the ratios in there just to remind my brain, oh, I'm just going to put ratios in there, okay? So if you're at 60, you're at a half over and then about 0.9 up, right? So half square root of 3 over 2. So the cosine is the half, the sine part is square root of 3 over 2, square root of 3 over 2, okay? And then I just multiplied across, got a fourth. Square root of 3 is 9. That square root is 3 all over 4. Subtract. I like to add the opposite, so I usually add the opposite. I get a negative 2 over 4 and simplify, divide by 2, divide by 2. Okay, same answer, which it better be. Otherwise, I'm wrong, right? All right, let's do the double angle. Now, again, sometimes on the double angle, people are like, why do they call it the double angle? You take half. Okay, what you have is double what you want it to be, okay? So that is why you take half, so that because it's twice what you would like it to be, okay? So that's why you take half. Why do we call it the double angle? Because it is double what you want. What you're given is double. You don't want it to be double. You wish it was half, but it's not. It's double what you want, okay? But in the formula, you take half of it. And again, this is what a student that doesn't know the unit circle would do, because they'd be like, oh, shoot, I love 60. I don't know anything about 120 because my teacher didn't teach me the unit circle. So they would be stuck doing this because they would really like 60, but 120 is double what they like. All right. So I look at my trig identity sheet. All right. And I use this one. There's 3 choices for that one. I did this one. Okay. And from up here, I already know these. So I have a half for my cosine squared. My sine is square root of 2 squared, square root of 3 over 2, sorry. A fourth and 3/4, subtract, same thing. And again, I get the same answer, which is lovely. All right, the half angle. All right, kind of the same deal. Is people are like, why is it called the half angle? That doesn't make sense to me. Okay, so it is half of what I want. Okay, so say you're given cosine of 22.5. And you're like, gosh darn it, it is half of 45. I really want 45 degrees. But what I'm given is half of what I want, okay? So in that case, they'd have to double it to get 45 because what they have is half of what they want, okay? So when you're doing the half angle, you double your angle because, it's half of what you want, okay? Now, again, I'm using something, that's on the unit circle, so that wouldn't be. But again, half angle you use when it is half of what you want. And so you're going to have to double it so that you can turn around and take half of it. And again, I know that gets confusing. So I wrote it right there. It's half of what I want, so I need to double it. Okay, so here we go. If I double 120, I get 240. And of course, if I divide by 2, I get 120. So it is mathematically equal. All right, now remember, you have to decide the sign. So if you look at where 240 is, the cosine's definitely negative. So I know the answer should be negative at the end. Again, I just leave a blank here for my ratio. I don't write the word, cosine of 120. I don't do that. I just leave a ratio, okay, or cosine of 240. I don't do anything. I just write the ratio. So again, 240, I put it in there. The cosine is -half. Get a common denominator. I did that over here. I know it's negative. I get 1/2. Now, to divide by this, you're going to multiply by the reciprocal, and you get 1/4 square root 1/2, and it's negative up front. Okay. All right. Usually on a test, I usually let my students choose. Like I give them something and it's like, you could do the double angle, you could do the half angle, you know, kind of depending on what you're given. All right, let's look at the next one. And I didn't solve this yet. Okay. So this is a bow tie problem, all right, because remember, bow ties can give you ratios just like the unit circle can give you a ratio, right? Unit circle gives you ratios of things we like 30, 60, 45, multiples of those. But what if you have ugly numbers, you know, square root of 7, square root of 13, then you're on a bow tie. All right, so let's look. Alpha is in quadrant 4, so I drew it here. All right, cosecant is, let's see what. So cosecant is the reciprocal of what? Sine. So sine is SOHCAHTOA. So sine is opposite over hypotenuse. So this is going to be hypotenuse over opposite. All right. Hypotenuses cannot be negative, or hypotenusi, I don't know. But the hypotenuse cannot be negative. So that's your 4. And plus, if you look at the 3, technically that's going down. So that's where your negative has to be. All right. So initially, I just drew that. Okay. Then tangent of beta. Tangent is what? SOHCAHTOA, right? So that's opposite over adjacent. So I came over into this quadrant. Opposite is 4 and 3. Now, if you're like, but there's no negatives, Julie. Well, a negative divided by a negative is a positive. And this is vectors going back. This is going down. Those are definitely negative. Okay. All right. So again, I wouldn't know that on this one. All right. Now, here you know A and B. Do you see it? You know your 2 legs. So this would be a Pythagorean theorem where you square, add, and square root. There's no subtraction on this because you know A and B. So -4 times -4 is positive 16. -3 times -3 is a positive 9. Adds up to 25. Square root C has to be positive. So no worries there. All right. This one, I know the hypotenuse. This has to be a subtract kind, right? Because I don't know A and B. I know the hypotenuse. This has to be a subtract kind. All right. So what do I know? I don't know. I can call this guy A squared. This guy, -3 times -3 is 9. You cannot get negatives when you do the formula because you're doing area. 4 times 4 is 16. -4 times -4 is 16. No way. And then do you see how I subtract the 9 over? Okay. And I could just write, I guess I could call that A squared if I wanted to. So subtract 9. So I get A squared equals, what is that? Is that 7? And then you can square root both sides. A squared is 7. Now you have to decide the sign. It might be positive, might be negative. We're going to the right, so it's positive. Okay. I wrote down the formula from my trig sheet. And then what I'm going to do is I am just going to write ratio, ratio, plus ratio, ratio. Okay. That's what I'm going to do here. Now, as far as sine and alpha beta, I don't even need to know the angles. This is going to spit out a ratio, right? The output. The input is angle. All right, fine. There's my angle. I don't even know what it is. I don't care. But the ratio is going to come from your bow tie. Okay, so sine of alpha. SOHCAHTOA. So what's opposite? -3. Hypotenuse is what? 4. Okay, that's for alpha. Let's go over here and do the cosine of alpha. Cosine of alpha is SOHCAHTOA, right? SOHCAHTOA. So adjacent over the hypotenuse. All right. Now I'm going to go to my beta triangle to get those ratios. Again, I don't know what angle B is. It's not, I mean, these numbers are not on the unit circle. So I could use my calculator to get, you know, an estimate, but I don't know what it is. All right, but it's fine. Cosine is SOHCAH, so adjacent over hypotenuse. Okay, and then sine of beta, SOHCAHTOA, opposite over hypotenuse. Okay. All right. And some of you know a 3, 4, 5, you know, so you're like, Julie, I didn't even do Pythagorean theorem. That's great. Love it. All right. So negative times a negative is a positive. Multiply straight across. This would be -4 on the outside, square root of 7 all over 20. And then we can write it, kind of put it at least in one fraction. That is not, you know, radicals don't add with integers, right? So I can just kind of write it together. All right, I'm going to pause and we'll go to the next page. All right, now on trig identities, if I asked you one, it would be a simple one. All right, you do need to know those for calc, right? And some calc teachers make you memorize them. All right, like the sum and difference and double, all that stuff. Some of them make you memorize. Basically, it's a good idea to know you can manipulate. Some of the major ways you can manipulate, is factoring out, changing things to like 1 over sine or 1 over cosine, factoring. Another key thing is cosine squared plus sine squared equals 1, doing the Pythagorean identity. I did the first 5 here. I am not going to put this on your guys' test, okay? So if you're in my online pre-calc, I'm not going to have you prove a trig identity. Okay, we didn't spend a lot of time on it. And the main focus for you guys would just be that in calculus, sometimes you have to use one to manipulate what you're given. Okay, but you should be able to do some of these simple ones. I didn't put any of the really hard ones here. Okay, so hopefully those went okay. All right, multiply. You should be able to add, you multiply straight across, have to have the same size. Subtract, you go straight across, you have to, distribute the subtraction through, again, have to be the same size. Multiplying, not so much. All right, so remember, I like to use a sticky note, and it's all about RC COLA, rows and columns. So I'm going to take this row, so I'm going to take 8 times 1 times 2 times, excuse me. All right, and then there's adding in between, just like normal. Now, what is this? RC COLA, there are 2 rows, 3 columns. Here, there's 3 rows, 2 columns. If these match, you can do it. So yes, I can multiply, right? The outside numbers tell you the size of my answer. So my new answer is going to be 2 by 2. All right, so let's do the math. I'm going to take that times that. All right, so what do I get? I get a negative 40. Plus 0 plus a negative 22. What is it? Negative 62. All right. And then I'm going to come over here for the next one. So what's that? 8, 2, and 14. So what is that? Is that 24, I hope? All right. Then I'm done because I have nowhere else to go. Okay. So now I'm going to do the second one. And again, if you guys have sticky notes, that would be good. All right. So, or use a piece of scratch paper that they give you. This is going to be positive 25, 0, and what? Negative 77. Oh boy. Oh, Julie, I should have a calculator. Is that negative 52? I think it's late at night. I think so. If I'm wrong, just fix it. All right. And then I'm going to distribute over here. So what is that? Negative 5, 12, and what? 49. Again, I should probably have a calculator. 5, 6, 7. Julie, is that 56, I think? That would be 50, 61 minus that. Yeah, I think I'm right. Now, do you guys get, I could check this on Desmos, all right? I'll do that in a second. This one, if I do rows and columns, rows go this, columns are coliseums, they hold it up, 2 by 3 and 2 rows, 1 column. These do not match. You cannot do this. Okay. Not allowed, right? Because when you try to, like write it down, it doesn't line up, right? The one thing has 3 things in it. The other has 2. All right. I'm going to pause for a second and we'll go look at this on Desmos quick. All right. I went ahead and edited these. And again, the way you do this is you hit new matrix, you put the sign and you just enter it all in there. But all right, hopefully I can delete this without, there we go, messing up. Okay, so I'm going to hit enter. I'm going to tab till the end. All right, enter. Okay, so what I want to do is I have to do which one first? A, this is my A, so I'm going to take A times B, because remember, order matters. All right, did I get this one right? Yay, I did. Okay, now on a test, I would want to see the scratch work. Okay, to prove that you know how to do it by hand. All right, okay, I'm going to stop here. This is what, number 28, and then we'll keep going.